Now, so that was about heating effect. Now let's talk about magnetic effects of current. Current also has a magnetic effect. He was the person. So Hans Christian Ørsted, the first person to observe, that whenever current passes through a conductor, it has a magnetic effect also. It can behave like a magnet. It produces a magnetic field around it. And he was the person who gave the idea, yes, that whenever current passes, we have a magnetic field around it, and that effect is called as magnetic effects of current. He got it. Accidentally, he was doing some experiment and he found that, oh, it is having a magnetic field also, and he gave the idea. So what is it? When electric current passes through a wire in any conductor, let's take copper wire or anything. So when electric current passes through a conductor, it has a magnetic field around the wire, and that effect is called as magnetic effects of electric current. Many a places we are using this concept. Many a places you must not even be knowing that you are also using these concepts at many places. Okay. The experiment, the animation you can see over here. In this, we have an electric circuit. Again over here, electric circuit which has a cell, which has a switch, which has a bulb. I am putting here just an indication that the current is flowing or not. Just for indicator, this bulb is required. Otherwise, no need of this bulb in the circuit. This bulb is an indication to show that the current is flowing in the circuit. Then I have taken a cardboard type, a wooden plank. You can take wooden plank or a cardboard, and take the wire, this copper wire connecting wire on him, and make 20-30 turns on that cardboard, and then connect to the circuit completely. Okay, and then place a compass needle nearby it. Do you know what is a compass needle? That needle itself is a magnet, and it is influenced in a magnetic field. The moment some magnetic field or a magnetic substance comes near it, it starts deflecting in the presence of magnetic field. Remember, a compass starts deflecting in the presence of a magnetic field. So here I have placed a compass near a coil of wire, and then this is my circuit. Now what to do? Switch on, nothing else. Let's see what happens. The moment you switch on the circuit, the compass deflects. The compass needle deflects. It is being deflected. What is the reason behind it? I am not deflecting it. No one else is doing that. Why does it deflect? If it is switch off, normal. Switch on, deflects. Why is it so? Reason? Magnetic effect. This coil is producing a magnetic field around itself. Due to this magnetic field, this compass deflects. So this was a demonstration to specify that a current carrying conductor produces a magnetic field around it. Okay, this magnetic field, how strong the magnetic field is, how much is the magnetic field, that all depends upon the current, how much is the current flowing, and what is the shape of the wire I am taking over them. That you are going to study in higher classes more detailed, how much is the intensity and how much everything. But at present, so whenever my circuit is on, when a current flows through a conductor, it produces a magnetic field. Okay, so now based on this concept, there are many of the things we are using in our daily life. Let's have a look on some of them. So in the magnetic effects of current, we have one more thing over here, electromagnet. Electromagnet, as the name indicates, magnetic effects of current, electromagnet. You can make an electromagnet at home also. A simple, you can see a simple device. Take a nail, iron nail, a long nail, take a connecting wires, copper, wind it around the nail, and then connect it to a cell. Connect it to a cell through a switch, or you may not even use a switch, you can do it. You made the connection, now you can use it. Now when you use it, the moment you switch on the circuit, you can see this nail is going to attract small pieces of iron. You can take small nails also, place it over there. When the circuit is on, then this nail will behave like a magnet. The bigger nail behaves like a magnet. Why? This coil, the current carrying coil, produces a magnetic field, due to which this nail, bigger nail, becomes magnet. It gets magnetized, and then it attracts these smaller nails. Okay, so this is a basic concept of electromagnet, magnetism in the presence of electric field. Okay, this electromagnet concept is used in many of the devices nowadays. Your loudspeaker, your mic, they all have electromagnets inbuilt in them. Even electric bell, the simple electric bell, you can call it as a gong bell. You must have seen in the school the trrrr bell, electric bell, the gong bell. A simple, you can see, this is a basic photo of a gong bell. Electric gong bell we say because there is a big disc type metallic on which it hits. This is the hammer which hits it and it rings. This also works on the concept of magnetic effects of current, electromagnetic effect, you can say simply. So the basic diagram, the basic circuit of an electric bell, you can see over here the gong, the hammer. We have the electromagnets, what we saw in the previous slide, a nail around which wires are winded. Same way we have a soft iron core on which the wires are winded, which behaves like an electromagnet, okay. And then there is a soft iron plate which we call as soft iron armature. So when the current is passed through the circuit, this behaves like a magnet, attracts the magnetic plate, and the hammer hits the gong. The moment this plate comes forward, the connection from this point, from the screw, gets off and the circuit is broken, magnetic effect finishes. The plate goes back, again the connection starts, the plate comes forward, and this to and fro motion makes this bell to ring. So this is the hammer which hits the gong and the bell rings. The basic concept of an electric bell, it works on magnetic effects of current. It uses electromagnet. So basic thing, there are many more things which works on magnetic effects of current. One of the, in a commercial thing, we use an electromagnetic crane, the electromagnetic crane which is used to lift heavy iron objects. It uses, you can see over here, you can see this plate is an electromagnet. You can see it lifting a bundle of iron pipes, metallic pipe, it can lift up. This plate behaves like a electromagnet, okay. The benefit of this, I can increase the strength of this electromagnet, I can decrease the strength of this magnet by increasing or decreasing the current. How strong I need an electromagnet, I can decide by making the current up and down. So this is the use of electromagnet. In dumping yards it is used in other factories also, industries also. Other than this, electromagnets are nowadays used in medical science also. Sometimes some injury happens, some accidental injury happens, due to which small bits of iron particles enter the body, which are removed by electromagnets. We use it over there also. And electromagnetic magnets are used in toys. There are certain, I told you, loudspeaker, microphone, they use electromagnets. So finally, what did we learn today in the whole thing? We studied about electric current, the path through which electric current flows, the electric circuit, symbols that we use in electric circuit. We studied about the heating effect, we learned about the magnetic effect, electromagnetism means electromagnets, and we studied about how things work, how the electric bell works, and different uses of electric current in a home, in a house, in industries, overall. Okay, till the time, explore the things. Bye bye, have a good day, see you next time, bye bye.